Hello dear friends, this is video number 6 in our series of Management of Information videos, and it's the first video in the second group. For more videos, please visit my Facebook page Healthcare Quality. In this video, we will talk about fundamental types of information systems. We have 6 types of information systems: transaction processing system, management information systems, decision support systems, executive support systems, expert systems, and office automation systems. Tracking operations with transaction processing systems. Transaction processing systems (TPS) is a type of information system that collects, stores, modifies, and retrieves the transactions of an organization. These systems help a hospital keep track of its activities. TPS must do their work quickly and reliably. Key functions such as admission, medical records, pharmacy transactions, and incident report surveys and payroll processing depend on TPS. It seeks time and cost efficiency by automating repetitive operations in large volumes. Architecture of a TPS. An event occurs. The event is recorded by keeping it into the computer system as a transaction, which is a representation of the event. Main information processes are collecting and storage. One or more TPS programs process the transaction against TPS data. The TPS program generates 2 types of output. It sends messages back to the user terminal, and it generates printed documents. The major characteristics of TPS. Large amounts of data are processed. The sources of data are mostly internal, and the output is intended mainly for an internal audience. The TPS processes information on a regular basis, daily, weekly, monthly, etc. Large storage database capacity is required. High processing speed is needed due to the high volume. TPS basically monitors and collects base data. Input and output data are structured, that's to say standardized. Low computation complexity is usually evident in TPS. A high level of accuracy, data integrity, and security is needed. High reliability is required. TPS are of 2 types: online interaction system and batch processing system. Online interactive systems involve a direct connection between the user and the TPS program. The user inputs a single transaction, and the program interacts with the user to process that transaction. For example, airline ticket reservation. The event is the request for a ticket, which is keyed into the computer system as a transaction. One or more TPS programs process the transaction against TPS data, which in this case includes the location of available seats at a certain time. The program generates two types of output. It sends messages back to the user and prints the tickets and perhaps a mailing label for sending them. The second type of TPS is batch processing TPS. For example, a check processing system. All checks received on a particular day are batched into a transaction file and stored by an identifying value, for example, account number. The batch processing program uses the transaction data to update the master file. The checking system master file contains customer checking account data, including account balances. This data is updated to create a new customer master file with updated account balances. Reports produced include overdrawn accounts, monthly summaries, and suspicious activities. Batch processing requires transactions to be grouped and processed together at a predetermined time. The major advantage is cost. Batch systems are considerably less expensive and less complex than online processing systems. Also, security is stronger and easier to maintain. The biggest disadvantage of batch processing is the time lag between the beginning of the transaction and the processed output. In transaction processing systems, the focus is data. Inputs, transactions. Outputs, organized data. Motives, large volume of data. And target people are operational people. The value of TPS are efficiency, paperless transactions, reduce manual data entry, speeds up transaction process, and elimination of redundant steps. And online transaction processes have more value, which is real-time systems, immediate feedback, real-time reports, and database updates. Now we come to the second type of information systems, which is management information systems. These are a level above TPS applications. They are not concerned with day-to-day operations, but rather with the longer-term management of operations. In the narrow definition, an MIS is an information system that facilitates management by producing structured, summarized reports on a regular and recurring basis. For example, in the ticket reservation system, a TPS is used to take orders and print tickets, and an MIS is used to measure and report the performance of each ticket agent. Such an MIS keeps track of the numbers and the amount of each agent's sales, and it regularly produces reports. The sales office manager uses this report to track agent performance, identify problems, and reward exceptional sales activities. The architecture of an MIS is shown in this diagram. Inputs, organized data from the TPS. Output, hard and soft copy reports, scheduled reports, on-demand reports, and exception reports. The user submits requests for reports to the MIS program. The programs process the TPS data by aggregating and reformatting it to produce reports, which are either printed or displayed at the manager's computer. In some cases, the reports are automatically generated, for example, every week or at the close of every business day. Each MIS is an integrated collection of subsystems, which are typically organized along functional lines within an organization. As we mentioned, outputs of MIS are scheduled reports produced periodically or on schedule, daily, weekly, monthly, etc. And demand reports gives certain information at a manager's request. And exception reports automatically produced when a situation is unusual or requires management action. Performance measures indicators used in many hospitals are MIS, used to assess the degree to which the appropriate and expected course of actions was followed, and the degree to which the expected outcomes was met for the following functions: clinical, resource, and service. In Management Information Systems, MIS, the focus is information. The inputs are organized data from TPS. The output are reports, motives, structured and routine problems. Target people are middle management. The third type of information system is decision support systems. Decision making is a process of choosing amongst alternative courses of actions for the purpose of attaining a goal or goals. The four phases of the decision process are intelligence, design, choice, and implementation. Online analytic processing enables managers and analysts to manipulate large amounts of detailed and consolidated data from many perspectives. It's done interactively in real time with rapid response to queries. Roll-up aggregation of data, for example, sales office data, rolled up to the strict level. Drill down display underlying detailed data, for example, sales figures by individual products. Slicing and dicing, viewing database from different viewpoints, often performed along a time axis. Decision support systems are interactive computer-based facilities that assist decision-making in less structured situations. They are often created to solve particular problems on an ad hoc processing basis. Therefore, in a decision support system, flexibility and adaptability are critical. Decision support systems are not structured, finished systems as are TPS and MIS, but rather they are collections of data and data processing tools used in creative ways to manipulate data. Like management information systems, they involve models of business activities. Unlike management information systems, however, Decision support system models are often quite complex. They are also dynamic. The decision support system user frequently changes the models to adapt them to the changing understanding and needs of a problem. For example, suppose a strike by the musician union forces the cancellation of opera performances. The management of the Opera Association wants to know the impact of revenue on each performance cancellation. A decision support system could process each agency data to produce this information. Ticket agencies may have a series of equations that predict sales of tickets on the basis of type of performance, day of the week, time of year, and so forth. As the strike progresses, the decision support system users may add to or otherwise modify these equations to produce information that's important in negotiating a resolution to the strike. Often users of decision support systems use the tools on their own without help from professional information system personnel. This figure shows the architecture of a decision support system. Data from the organization's TPS and MIS applications is input to decision support system programs, along with data from external sources and decision support model data. The user interacts with the decision support system online. Requests are made, models are created or adjusted, data is manipulated and stored, and so forth. The output of the decision support system programs can be text, structured reports, or graphics. The decision support system consists of three subsystems, which are data management, model management, and user interface. This figure shows how these subsystems could be arranged. In the decision support systems, the focus is decision. Inputs are internal and external data. Output, decision analysis and alternatives. Motives are semi-structured and unstructured problems, and target people are top management. The fourth type of information systems is executive support systems. They support the information needs of very senior executives by summarizing and presenting data at the highest level of aggregation. They usually involve presenting reports in standard formats, and they often involve graphics. At the same time, they can show further details when, for example, an executive sees something that seems curious and wants to see the underlying data. The main characteristics of executive support systems are graphical, easy to use interface, high level with drill down, key business and industry data, integrates many sources of data, and timeliness is crucial. This figure shows the architecture of an executive support system. They accept data from all of the other types of information systems. It also accepts input from personnel who supports the executive, such as administrative assistants. The fifth type of information systems is expert systems. How knowledge is processed with expert systems. An expert system uses reasoning to render advice, make recommendations, or diagnose problems. To do this, the expert system processes input data against a knowledge base. In most expert systems today, the knowledge base consists of a set of rules. Expert systems based on collections of if-then rules were the dominant technology for artificial intelligence in the 1980s and were widely used commercially in that and later periods. They are slowly being replaced in healthcare by more approaches based on data and machine learning algorithms. For example, one organization uses an expert system to make recommendations to employees about the most effective means of shipping parcels. The user inputs size, weight, destination, and time constraints into the expert system. The system processes this data against a knowledge base of rules that tells which companies handle specific sizes of shipments, under what time constraints, and at what costs. Thus, the system can make a recommendation about the most cost-effective transportation means. An expert system encodes knowledge that can take a human several months, years, or even decades to learn. Using them, new employees can be productive more quickly. Also, when experienced and seasoned employees are prompted or otherwise leave the department, the benefit of their knowledge is retained since it has been incorporated into the rule base. Another example is an output patient care and follow-up program. Register all healthcare providers in the area and provide the analysis tools that allow the hospital staff and social workers to recommend doctors, clinics, pharmacies, and other related services to assist the patient after release. This figure shows the architecture of an expert system. An expert system has four major components. The interface engine processes the knowledge base to achieve the goal stipulated by the user who is communicating via the user interface. The explanation system helps the user by describing the need for certain information or by explaining the basis for recommendations that are produced. And finally, the knowledge acquisition system is used by some who has expertise in the problem to create, add, or change the knowledge base. The sixth and last type of information systems is office automation systems. They enhance communication effectiveness. These systems create, store, modify, and process interpersonal communications, whether in written, verbal, or video form. At first, computer systems were used as word processors. Over time, interconnected computers let users share word processing files and send messages electronically Today, a wide variety of office automation systems exist. The media involved are so disparate. Computers, telephones, television screens, copy machines, graphics plotters, and audio equipments, as shown in this table. Dodge Engelbart, one of the pioneers in office automation systems, predicts that the real power of such systems will not be realized by improving our productivity in working as we do today. Rather, the greatest benefit will be to let people think, communicate, and work together in new ways. Office automation systems can change the way people view, conceptualize, and solve problems. For example, in hypertext systems, text illustrations, graphics, data programs, audio, and video can be integrated into electronic documents. Users read such a document sequentially or at random, just as books can be read. Unlike books, however, hypertext documents let users follow many different pre-established paths through the document, or users can establish their own paths. This figure collects all falsified types of information systems. Thank you.